1977, the Voyager 1 space probe was launched into space to study the outer solar system. The two Voyager space probes have now become the longest operating spacecraft in spaceflight history. 43 years later, Voyager 1 is now approx 25 billion kilometers from Earth and traveling nearly at 61,000 kilometers per hour. Despite being so far from home, we are still able to communicate with the space probe. But why do engineers always have to face issues in order to communicate with the space probe? To answer this, we need to understand how Voyager 1 receives and transmits data from 25 billion kilometers away. A 20 kilowatt signal is transmitted from Earth to Voyager 1 using radio waves. It takes almost 20 to 23 hours to reach the space probe where its sensitive antenna picks up the signal. Voyager starts sending data back to Earth using a 20-watt signal. As it travels through space, the signal strength weakens, and by the time it reaches Earth, the signal is barely detected. In order to communicate with objects this far away, it doesn't really matter how strong the signal is, as long as you have the receiver that is sensitive enough to pick up the signal. NASA uses the Deep Space Network to communicate with Voyager 1, which consists of 3 main antenna complexes placed around the Earth. Each complex has a huge 70-meter antenna, along with multiple 34-meter antennas, which are combined to pick up signals that are thousands of times weaker. The Deep Space Network spends several hours each day listening to faint signals from Voyager 1, and so far, it had continued to talk back to us until November 2023. On 14th November 2023, Voyager 1 stopped sending readable science and engineering data back to Earth as there was an issue with one of Voyager 1's onboard computers, called the FDS or Flight Data System, which is responsible for storing and handling all the scientific data and images taken by Voyager 1. The data in FDS is stored in the form of ones and zeros, or the binary code. The telemetry modulation unit began transmitting a repeated pattern of ones and zeros as if it were stuck. After studying all the problems, the team discovered that a single chip responsible for storing a portion of the FDS memory, including some of the FDS computer's software code, wasn't working. The loss of that code rendered the science and engineering data unusable. Unable to repair the chip, the team decided to place the affected code elsewhere in the FDS memory, but no single location was large enough to hold the section of code in its entirety. So they devised a plan to divide the affected code into sections and store those sections in different places in the FDS. To make this plan work, they also needed to adjust those code sections to ensure, for example, that they all still function as a whole. Any references to the location of that code in other parts of the FDS memory needed to be updated as well. The team started by singling out the code responsible for packaging the spacecraft's engineering data. They sent it to its new location in the FDS memory on April 18th. About 45 hours later, when the mission flight team heard back from the spacecraft on April 20th, they saw that the modification worked. For the first time since November, NASA's Voyager 1 spacecraft is returning usable data about the health and status of its onboard engineering systems. In the coming future, the team aims to relocate and adjust the other affected portions of the FDS software. These include the portions that will start returning science data. If you liked this video, be sure to subscribe our channel for more amazing upcoming space contents.